Welcome to a brand new explainer. If you just glance at the calendar, June 8th probably seems like, well, a totally normal day, right? But actually, it happens to be one of the greatest, most incredibly serendipitous dates in the entire history of mathematics. And today, we're going to show you exactly why. On this exact same date, spanning totally different centuries and countries, some absolutely brilliant minds were born. We're talking about people who literally laid the groundwork for the tech in your pocket, the games you play, and the modern world we live in today. Let's meet them, one by one. Okay, let's dive right in. Have you ever actually stopped to wonder how your phone's GPS manages to pull off what it does? Like, how does it instantly calculate the absolute fastest route through hundreds of overlapping roads, dead ends, and traffic jams? It does it in a fraction of a second, solving a maze that would literally take a human hours to figure out. Well, believe it or not, the answer takes us all the way back to June 8th, 1745. Enter Caspar Wessel, a super talented Norwegian-Danish surveyor. So Wessel cracked a huge problem for mapmakers. Before him, if you wanted to deal with distance and direction, well, you had to use these really clunky, totally separate calculations. You'd have one set of numbers for how far to go, and an entirely different set of complex math for which way to turn. It was a headache. But Wessel, he came up with a visual way to combine them into just one single mathematical step, an arrow called a vector. By giving direction and distance a unified language, he created the exact geometric foundation that our modern navigation algorithms use to zip you across town today. Suddenly, physical space wasn't just something you walked through, it was completely computable. It is just wild to think about, isn't it? Every single time you drop a pin on a digital map, you're secretly using the incredible mathematical vision of an 18th century surveyor. Without his work, that little blue dot on your screen simply wouldn't know how to move. Okay, we're staying on June 8th, but let's fast forward a whole century to 1858. Different country, totally different challenge. Imagine this for a second. What would you do if a university looked at your hard work, your passing grades, your undeniable talent, and just flat out told you, nope, you're not allowed to graduate, just because of who you are? Well, that brings us to the unstoppable Charlotte Angas Scott, born exactly on this date in 1858. She hit that exact invisible wall in Victorian England. She proved she was absolutely brilliant by placing 8th in her Cambridge University math exams. 8th, that is a phenomenal feat. But, get this, she was denied her degree simply because she was a woman. Instead of giving up, though, she took her genius across the ocean. She pioneered algebraic geometry, which is essentially using equations to perfectly describe complex curves and shapes, turning visual geometry into hard, calculable numbers. Then she became the first head of math at Bryn Mawr College in the US, training a whole new generation of female thinkers. Her story leaves us with such a powerful takeaway. Brilliance just cannot be hidden forever. And numbers? They really don't care about outdated, unfair rules. Math is the ultimate equalizer. All right, still the same date, but just 2 years later. We're going to stay in England for this one because things are about to get a little mind-bending. Think about your favorite video games for a second. How exactly do they build these massive, hyper-realistic 3D worlds on a completely flat TV or phone screen? Like, how do we build dimensions that we can't even physically touch? To understand the secret of mapping higher dimensions, we have to look back to June 8th, 1860, and an absolute visionary named Alicia Boole Stott. Now, get this. Alicia had zero formal math education. None. But just by playing with simple wooden blocks, she figured out how to visualize and map out complex, four-dimensional shapes called polytopes. Think of a polytope like a multidimensional shadow. It's a 4D version of a regular 3D cube. She mapped these higher dimensional worlds using nothing but her imagination and pure geometric logic, literally seeing shapes that no human eye could ever actually see. She was performing mental gymnastics that baffled even the top professional mathematicians of her time. It's honestly amazing to think about. Our modern 3D screens are basically just windows into higher dimensions that were first unlocked by a woman just playing around with wooden blocks. I mean, one date, right? So many incredible stories. But we're not done yet. Let's push right into the 20th century. Today, we rely on these complex algorithms to track invisible threats and spot hidden patterns to keep us safe. But where did that whole concept even start? That traces back to a guy born on, you guessed it, June 8th, back in 1903.
Evan James Williams, a brilliant atomic physicist.
So, during World War II, Allied ships were taking heavy hits from German U-boats lurking underwater. It was a massive, terrifying problem. But Williams used a brand new branch of math called operations research, which is basically the science of making better decisions using statistics and probability. Instead of just guessing where these submarines were, he analyzed the chaotic data of ocean patrols to find hidden mathematical patterns. By optimizing exactly how planes search the oceans and where they set their depth charges, he helped turn the tide of history. He literally showed us how algorithms can save lives. The big takeaway from Williams' work is super clear. Math isn't just a bunch of abstract numbers on a chalkboard, it is the absolute ultimate tool for solving real-world, life-or-death mysteries. So, let's pull the whole picture together. Look at this timeline. Every single person we talked about today, across all these different centuries, countries, and disciplines, was born on the exact same day, June 8th. From mapping the globe to breaking down social barriers to visualizing the fourth dimension and hunting submarines. And you know what? They all asked the exact same fundamental question. What is the pattern hiding inside the chaos? And because they dared to ask that question, our world today is shaped by GPS navigation, insane 3D graphics, and algorithms that keep us safe. So, as you look around your world today, what amazing pattern will you discover? Thanks so much for exploring this totally fascinating date with me, and I really hope this explainer inspires you to keep looking for the hidden math all around you.